Remembering that the internet is best at caching HTTP GET method requests, it makes sense that GraphQL should provide a way for us to take advantage of that, especially for high-volume sites using GraphQL. There is currently nothing in the GraphQL spec for that, so Apollo has invented their own solution that involves their own protocol for making this happen. Lucky for us, if we use both an Apollo server and Apollo client, we have very little setup necessary to make this work. In the clip following this, I'll go through the details as well as show you the network traffic associated with using this new Apollo feature. For now, let's talk about how this works from a high level, including the motivation for Apollo creating it. As you can imagine, as applications get more complex, the GraphQL query string that needs to be passed to the server can get quite large. These strings can be significantly longer than a GET request can handle, and since we know we want to be able to support GET requests, this is a major blocking point. Not only that, if we were to send these queries, it's a big waste of bandwidth since we are repetitively sending the same query. Apollo solved this by inventing a new protocol that helped them to store queries from the client that could be referenced with a unique key without having to resend the full query multiple times. That is, the first time the client sends a GraphQL query, the server remembers it in its cache and returns to the client the result of the query. What does this protocol actually look like? Let me explain by following a single query from a GraphQL client to the GraphQL server for the first time. Then talk about subsequent requests. First, it's important to understand that the hash of a query is deterministic. That means we can take our query, run it through a hashing algorithm, and every time that query will generate the same hash value. We can't go the other way, however. That is, we can't take that hash value and turn it back into a query string. But we can know for sure whether the server has the query already in its cache. So here is the flow, starting with the Apollo client. Just before the Apollo client would send a query, it calculates the hash for this query. It does what we call an optimistic request. This means it sends an HTTP GET call to the server, hoping the server can process it. Assuming the server has never seen this request before, it returns to the client a rejection and does no processing. Then, the client, after getting rejected, sends the full query back over a POST request to the server. The server executes the request, then responds with the full results. Meanwhile, though, the server calculated the hash of the request the same way the client does and stores the full query along with the hash for the next time. If all your requests are unique, which is highly unlikely, this is a bad plan because it took us 2 round trips to the server to get the response we wanted. However, likely you'll send the same request over many times, so the next time you make the request, the path is just like this. Your client sends the request with just the hash, and since the server has the full request stored, it can execute it and return directly. Just one request with a small payload over HTTP GET, and the full result is returned. Again, like I said earlier, since this is over GET, it's easy to configure a CDN to cache the results for us, and then next time, our GraphQL server never even needs to see the traffic. Let's build this out in our next clip. Because of the tight integration between Apollo client and server, the implementation details necessary to add automatic persisted queries is quite simple. It turns out we do not need to make any changes to our Apollo server code, just to our client. The Apollo server has by default everything built into it we need. So I've got our Apollo client open here in VS Code. That's in the folder Apollo Client React App. There are 3 node packages we need to install. To do that, enter the command npm install Apollo link persisted queries, Apollo link, and Apollo link HTTP. Just a quick mention though, at the moment there's a dependency bug in the Apollo library that appears if you are running npm 7, so if you are, either switch to yarn or install npm version 6 and you'll be fine. Open the file apolloclient.js and let's update it to include what's necessary to enable automatic persisted queries. First, import our 3 new libraries at the top. Then create a new link object by using the following Apollo link import. Set useGetForHashQuery to true, and that takes care of switching from post to get for us. And also, notice that if you are running on a localhost port other than 80, you'll need to mention the fully qualified domain like I've done. Otherwise, just /GraphQL is enough in the URI spec. Lastly, remove our URI from where we instantiate the Apollo client and add the link object instead using ES6 shorthand syntax. That's literally all we need to do. Let's launch our client app with npm run dev. Then, instead of Chrome, let's browse with Firefox as it's got a nicer network debugger interface. I've also brought our terminal window over for the server so you can see it at the same time as the React app running in the browser. Let's browse to the speakers page we wrote previously. Notice we have an HTTP GET for our GraphQL command. Before that, it would have been a post. Expand the header of the GET command. Notice the variables are passed in as before, but the query itself is just the persisted query hash, and it's not very long. Let's right-mouse on the GET and resend it to our Apollo GraphQL server. Check out the response. It's got all our data because the server could look up the query based on the passed-in hash. To prove this is working, let's stop and restart our Apollo server. Just Control-C, then npm start in our terminal window. Now resend the query again. Browse to the response. We get an error saying persisted query not found. Exactly what we should have expected. The only way to get this query registered again is to refresh our browser, and our Apollo client and server will exchange messages behind the scenes for us and re-register the query. I hope you see like me that this new feature is a game changer for GraphQL when it comes to enterprise scale applications, because now being able to leverage HTTP GET with GraphQL along with persisted queries in our Apollo server, we have now infinite scale out available to us. The big takeaway for both this clip and the module is now, with these advanced cache features, GraphQL has arrived as a significant player in the ecosystem of high-performance websites. In the next module, we'll look at two other big potential game changers for GraphQL: server-side rendering your React app with Apollo Client and serverless deployments of your Apollo GraphQL server.